In today's tutorial, we'll be building a very simple escrow smart contract that allows you to deposit funds to pay for goods within the smart contract, and those funds would only get released to the seller once you've received the goods. Now you may ask, why are escrow contracts important? Escrows are used in financial transactions where we may not trust a third party that we're trying to receive goods from. So for example, if you were buying goods off a seller on, say, a website like Kijiji or on Instagram, you may be skeptical about paying for those goods upfront and may be worried that the seller may not come through with the goods or you may not receive the goods. Using an escrow allows you to have a third-party service that would hold on to the funds until you receive your goods and then send those funds to the seller. Now, escrows are quite expensive to use. You may have to pay a fee for the service. If you are using an escrow smart contract, it will be much cheaper than using an escrow service. Now, let's talk a little bit about how escrows work. So with escrows, you would typically have a third-party service that you as the buyer would send funds to. Now, the third-party service would hold on to the funds and wait for the items to be delivered by the seller before then releasing the funds to the seller. Now, if the seller does not deliver those goods to you, or the items are not delivered to you, or they're delivered in bad condition, the escrow service would simply return the funds back into your account. And that's pretty much what we're going to be building today. So if you've got a friend or if you've got someone that you're looking to buy something from and you would like to have a smart contract manage a transaction between the two of you, you're in for a treat. So let's get into it. So first, we'll go through a sketch of how our escrow smart contract is going to work. We're going to think through the logic for our application before we get into writing the code. So as you can see here, we have the buyer transfers the money to the escrow contract. So once the money is transferred to the escrow contract, the funds are actually stored within the escrow smart contract. Now, something else that we can do to make our application more interesting is that we can actually have an API service that would notify the seller or any other third party involved in the transaction that the contract has received some funds. But for the purpose of this tutorial, we're not going to be touching on building out the APIs to notify participants in our smart contract that anything has occurred on the contract. Once the smart contract receives the funds, the seller is aware that the funds have come into the smart contract, and now they can set off a chain reaction. So they can start to ship the goods to the buyer. So the seller informs the smart contract that the items have been dispatched. So the seller would also have an entry point within our smart contract that they can call, letting the smart contract know that the items have been dispatched. And we can update the state of our smart contract to items dispatched. Now, remember that our smart contract would need to keep track of the buyer's address just to make sure that we know exactly where the money is coming from, and if the buyer needs to reclaim their funds, we know exactly where to send the money to. We also need to keep track of the seller's address, and the reason for this is that if a third party who is not the seller, who is not the recipient of the funds, comes to our smart contract to claim those funds, the smart contract is going to deny them from being able to access the funds because essentially the funds are not meant for them. Now, our smart contract would also hold the funds as well, like we said earlier, and it will also keep track of the state of the delivery. Once the seller informs the smart contract that the items have been dispatched, we're also going to be working with a delivery company here. So in this smart contract, we are actually going to have three players. We're going to have the buyer, we're going to have the seller, and we're also going to have the delivery company. Now we're going to keep track of the address of these three parties, and I'm just going to make a change here to our notes, and I'm going to add keep track of the delivery company's address. The delivery company is responsible for delivering the items to the buyer, and I think it would be better if the delivery company were to confirm that the buyer has received the goods rather than the buyer themselves confirming that they've received the goods. Once the items are dispatched, the delivery company can go to the buyer's address or to the buyer's house or to the buyer's office and deliver the goods. And once they've delivered the goods, that's going to send a message to our entry point, letting our entry point know that the items have been delivered. Now, once the items have been delivered, the contract itself sends the Tez to the seller, right? So no, we do not need anyone to interact with this contract to move the money to the seller. We can simply notify the smart contract that the transaction has been completed and the items have been delivered, and the Tez will be transferred to the seller. In a case where the item is not dispatched, you could check if a certain amount of time has elapsed, and if the item has not been dispatched between the time where the contract was deployed and the time where the contract is being called. we can have the buyer reclaim their Tez, and we're going to demonstrate that today as well. So we're not going to go into how to set a time on when a buyer can reclaim their Tez, but we're going to be talking about how to reclaim your Tez from the smart contract, assuming that the seller does not owe their own end of the bargain and your items were not dispatched. Now let's get into the code. So as usual, our first step would be to navigate to the SmartPy web IDE, which is located at smartpy.io/IDE. So once you're in the IDE, the first thing that you want to do is to import SmartPy, the SmartPy library. And then you have your declarator sp.module, and then you define your main method. And then we start to write out our Escrow class. Now remember that our Escrow class inherits from our sp.contract, which is our smart contract module. And then we can define our constructor. And in our constructor function, we'll take in a buyer's address, a seller's address, the delivery company's address, and selling price. So when the contract is originated, we would pass in the buyer's address, we'll pass in the seller's address, we'll pass in the delivery company's address, and then the selling price. Now we define our storage. So the buyer's address is going to go into the storage. We're also going to put the seller's address in the storage as well, and the delivery company address and the delivery state, and then the selling price. So all of this is going to go into the storage. Now, next thing that we need to do is we need to start to define our entry points for this smart contract. And the first entry point that we're going to have is a deposit entry point so that we can deposit funds into the contract. So the first thing that we want to check is that the delivery state is awaiting payment. So if that is true, we allow the rest of the code to continue to execute. Then we check if the sender is the buyer. So we want to make sure that the buyer is the one trying to deposit funds into this contract. And then we also make sure that the amount that is being deposited by the buyer is actually equal to the selling price. Because if the amount deposited by the buyer is less than the selling price, it means that the seller is not going to get the full value for the item that they've sold or they're about to sell. And once all of that holds true, we can update the delivery state to payment received. Now, one thing to point out here is that once you call the amount method when you're passing the funds to the contract already knows to store that amount within the contract. Now we need to get into our next entry point. The next entry point is the dispatch items entry point. This is the entry point that we call to let the contract know that the items have been dispatched and should get to the buyer anytime soon. So the first thing that we want to check is that the person trying to call this entry point is the seller. So we check that the sender is the seller's address just to make sure that only the seller has access to call this entry point. And then we can update the delivery state to items dispatched. And lastly, we move on to our next entry point, which is to confirm delivery. Now, remember that only the delivery company can confirm delivery of the items. So the first thing that we check is that the person sending the transaction is the delivery company's address. So that's where the transaction is coming from. And if it's not the delivery company's address, we're going to throw an exception and we're going to show the error, you do not have permission to confirm delivery. So we can call the balance method within the SP library or within the SmartPy library to check that the balance within the contract is greater than zero Tez. As you can see, we're also calling the Tez method within the SP library as well. And if the balance is not greater than 0 Tez, we're going to throw an error and we're going to raise an exception and show the message there are no funds to transfer. And then we can update the delivery state to items delivered. And then finally, we can send the Tez or the tokens within the contract to the seller. So send method takes in two parameters, the seller's address and then the amount is sent. And we're sending the money from the balance and we're sending it to the seller's address. And then we're going to have another entry point for reclaiming funds. So if the buyer is unable to, if the seller is unable to fulfill the transaction, or the seller or the buyer is no longer interested in buying the items, they can simply reclaim their funds. And to reclaim their funds, first we check that the delivery state is that the items have not been dispatched yet. Because of course, if the items have been dispatched, then the buyer should not be able to reclaim their funds anymore. And if the items have been dispatched, we're going to throw an error to say your items have been dispatched, you cannot reclaim your funds. But if not, we can continue executing the transaction. So once again, we check that only the buyer is able to call this entry point. And then we simply send the buyer back the funds to the buyer's wallet address. All right, so now let's get into writing our test. So the first thing that we want to do is we want to call the add test method of the SmartPy library, and we want to pass the name of the test, which is Escrow. And then we're going to define the test method, and we need to define 3 accounts that we're going to be interacting with, or we're going to be using to interact within our smart contract. And we have the buyer account, we have the seller account, and we have the delivery company account. These are all test accounts that we've used or that we've initiated using the SmartPy library. And then we want to create a test scenario using our main method. And the first scenario that we want to test for is that only the buyer can deposit funds. But before we can start our test, we need to originate our contract. And to originate our contract in our test method, we're simply going to call the contract, right? So we're going to call the contract, and we're going to pass in we're going to initialize it. We're going to pass in the buyer address, the seller address, the delivery company address, and then the selling price. And then we're going to merge the scenario and the contract together so that we can start to run our tests. And the first test that we want to run is that we want to call the deposit entry point as the buyer. So we're calling the deposit entry point as the buyer, and we're passing an amount of 50 TES into the contract. And then we want to make sure that the balance actually updates correctly to 50 TES. Now, the next test that we want to run is that we want to check that only the delivery company can confirm delivery of the transaction. And when we call the confirm delivery entry point, and we're going to pass the sender of the transaction as the delivery company. And then we just need to verify that the delivery state gets updated correctly to items delivered. Lastly, we want to check that if any other person apart from the delivery company tries to confirm delivery, it should fail. So we're going to call the confirm delivery entry point again, but we're going to send the message from the buyer instead, and this particular line should fail. So let's execute our test to make sure that everything works correctly. We can see here test that only the buyer can deposit funds. We can see that the balance gets updated to 50 TES. The delivery state gets updated to payment received as well. We can see the buyer's address, the delivery company's address. These are all the things that are currently in our storage. We can see the seller's address, and we can see what the selling price is. Now, check that only the delivery company can confirm delivery. Again, we see that the balance is still 50 TES, but we can see the operations here. So if you look under operations, we can see that this 50 TES is actually being transferred out of the contract, and it's being transferred to this wallet address, which is the seller's wallet address. So if you compare this and this, you can see that they are pretty much the same. The seller's address and the address that is receiving the 50 TES. And lastly, we can see that if we try to confirm delivery as the buyer, this fails because the buyer does not have permission to confirm delivery. And that's pretty much how we write our test. And to deploy your contract, you simply come up here to deploy Mikkelsen contract and click the deploy Mikkelsen contract again. As long as you have a test account, you can pretty much deploy this to the Ghostnet. So that's pretty much how you write a very simple escrow smart contract on Tezos. And from here, you can simply deploy this to the Tezos blockchain. You can integrate this with your dApp and get your friends and your family to interact with it, or anyone that you're trying to do business with. Remember that escrows are a good way to keep yourself safe when you're doing business with third parties that you may not trust. And it's also a cheap and affordable way to do it as well, because rather than paying a third party a percentage of whatever amount you're trying to move or whatever the cost of your item is, you would only need to pay gas fees when you use an escrow that is deployed as a smart contract on the Tezos blockchain.